Hi, so if you clicked on this video, you're probably on the hunt for your new LED strip or you're just getting started with it, and you most likely got lost among with the many different types and models that are out there. So usually the key difference are that they either display only a single color or multiple colors at the same time. They can integrate with Alexa or in Google or both or sometimes none. And each brand has their own app, which means that you will have to create another account to use your lights. These solutions are pretty amazing because they most likely are plug and play, and you have to create an account and install the app on your phone and you are ready to go. But if you're like me and you prefer to have more control on your devices and tinker with it a little bit, what I'm going to show you today might be a really good alternative. It will allow us to do most of the things that I mentioned before and probably will cost you less, and you won't need an app or even an account in order to control them. It will allow you to do some effects such as this, or even this. It also allows you to sync the LEDs with other LEDs that you have running the same software, although I won't be covering that in this video, but let me know in the comments if you want me to do that. You'll need an ESP8266 or an ESP32, a power supply. I usually go with the phone charger and USB power cords, some LED strips, and some jumper cables. There are many different LED strips that can be used. Here's a table with the ones that are supported by WLED. I'll be using the 5V one, namely the WS2812B, but you're free to use whatever you want as long as they follow the one supported by WLED. So in this case I'll be using the soldering iron in order to solder the LED strips and the jumper cables. Now, if you don't feel comfortable doing this, or if you don't have a soldering iron, there are some alternatives which you can use, such as these pieces that allow you to connect the jumper cables and the LED strip without having to solder anything. Let's start with the software side. Head over to the WLED GitHub, and I'll make sure to leave the links down in the description. And make sure to check this page because it has all the documentation that you need, the features, what is supported, the same list that I've showed you with the supported LED strips. So please make sure to check it if you have any questions. And go to the releases on the top right. At the time of this writing, the current version is the 0.12.0, and download the version for the microcontroller that you'll be using. In my case, I'll be using the ESP8266, so I'll download this binary file. If you're not sure which binary you should use, just check this documentation page, which has the information about the binary according to the microcontroller that you are using. Now that we have the binary that will control the lights, we need to find a way to send that binary to the microcontroller. And that can be achieved using the esphome-flasher. Go to the GitHub of the esphome-flasher, I'll leave the link in the description, and head over to the releases, same process as we did with the WLED, and download the file for your operating system. I'm using Windows here, so I'll be downloading the Windows file. Now, before you plug the microcontroller into your PC, you have to set it to the flashing mode, and this usually consists by pressing the flash button and keeping it pressed and then connect the USB. This process might vary from board to board, but from those that I've tested, the process is always the same. Just keep pressing the flash button and then plug the USB. After plugging the microcontroller into your PC, just open the esphome-flasher file that we've just downloaded and press the refresh and see if your device shows up. If your device does not show up, repeat the same process, and if it keeps not showing, chances are that you might have to install drivers. For instance, in my case, I had to install the CH340G driver in order to be able to use the microcontroller. Then you just have to press the firmware and browse for your WLED and press the flash button. This usually takes less than a minute. And once this process has finished, the device will reboot automatically and it will create an access point, allowing you to connect your smartphone or your laptop into that access point and configure the WLED server. So using your smartphone or your laptop, connect to the WLED access point. As you can see here, I'm connecting it through my mobile phone. And once it connects, it says that you need to sign into the network. You don't need to do that. And you can jump right into the controls or configure the Wi-Fi. In this case, we are just checking if it works, so we'll not configure Wi-Fi right now. We'll do that later. So this is just to confirm that the software was correctly flashed into the microcontroller. There might be cases where you can't connect to the access point, or you can connect but you can't see the pop-up. And if you don't see the pop-up but you are connected to the access point, head over to your browser and type WLED.me, and that should redirect you to the same page. In this case, on the LED strip side, we have that the white is ground, the green is data, and the red is power, which are the 5 volts. And here's an image with the connections. As you can see, the V in my case, are the 5 volts, the yellow is the ground, which is the white on the LED strip, and you have here the green connected to the D4. By default, WLED uses the GPIO pin number 2 as the connection to send the data to the LED strip. But as you can see, I'm using D4 on my board. So this means that although it is labeled as D4, if you check out the pinout, you can see that D4 is actually GPIO pin number 2. So you need to check your board pinout and see if the GPIO pin 2 is the same as labeled on a board or a different one. Now you might be wondering, how many LEDs can I use with a single power supply? Well, it depends. In this case, because I'm using the WS2812B, and by looking at the datasheet, I can see that each LED actually consumes 60 milliamps at full brightness. And because we are talking about RGB, we actually have 3 LEDs inside the major LED. In reality, the square, which has the LED, actually contains 3 different LEDs, one for red, one for blue, and one for green, which means that each of those LEDs actually consumes 20 milliamps. So when the 3 are at full brightness, that means that we have 60 milliamps. If you're using your smartphone as a power supply, chances are that charger has 2 amps or 2000 milliamps. So that divided by 60 gives you around 33 LEDs. So in reality, you should be able to use even more than that because we are using 6 milliamps, meaning that we are using full brightness, but you will most likely be using for different effects and you won't be even using white. So you won't be using all the 3 LEDs at the same time. So now that we have everything set up, it's time to test it. And for that, as you can see, I have everything ready. So I'll just turn off the lights and connect the power supply, and hopefully we'll see some lights. After the device starts, it will create an access point which will allow us to connect to it and do our configurations. So here I'm just waiting for the WLED access point to show up, and once I connect to it, I can see the same settings that we saw before. So jumping into the controls, we can control everything by changing the colors. As you can see, we have tons of color presets, a lot of effects, and these will all be configurable from this point. So we can change the modes, we can change the brightness, the speed, the duration, the intensity of the effect. So everything is controllable through these menus, as you can see. Scrolling through the effects, as you can see, the list goes on and on and on. There are a lot of effects for you to search and decide which one do you prefer. So take some time to look into it and play around with it. And if you press the config button, this menu shows up and you can configure the LED preferences here by defining the number of LEDs that you want to use, the max current that your power supply can handle, and there's not much here for us to do now. Connect to your Wi-Fi network by typing the SSID and the password, and it should be ready to go. So then after doing that, just press save and connect and your ESP will reboot. If it takes too long, you can force the reboot or just wait, and after some time WLED will show on your network. So connect to your home network once again, like I'm doing here, and in order to make it easier, you can download the WLED app, and the reason why I'm saying that it's easier is because the WLED app has an option to search for new WLED devices. So as you can see here, it found my WLED in my office and a new one, which is the one at .93. As you can see here in this menu, I'm doing exactly the same as we're doing through the browser, but instead we are using the app, and the device is already connected to my network. As for the configurations, that's everything that you need to know for now, so go ahead and explore your device. So I hope that you found this video useful. Let me know in the comment section if you have any questions and if you want more videos like this. If you liked, press the like button and consider subscribing, and have a nice day.